Okay, what we're going to do is talk about doing the first and second derivative test for this function, and we're going to locate any maxes, mins, inflection points, and then use those to be able to sketch the graph. So let's start with f of x is equal to x times quantity 4 minus x to the 1/5. Now there's a pattern with this. UdV plus VDU when you're doing the derivative of a product. So this is going to be U, this is going to be V. So I'm going to do x for the first derivative. I'm going to do x times the derivative of V, which is 1/5, 4 minus x to the negative, to the 1/5 minus 1, times the derivative of the inside, which gives us a minus 1, plus V du. So this is 4 minus x to the 1/5 times the derivative of x, which is just 1. So we have to simplify this. This is going to give me, so we got like x over 5 out of these. This is going to go to the denominator. So we're going to have, this is going to be a minus 4/5. So we're going to have a 4 minus x to the 4/5 in the denominator. And we've got our negative 1 here. Stick the negative sign in there. Plus, this is going to be 4 minus x to the 1/5. So we'll make them both into fractions. So to combine these, we have to have common denominator. And the common denominator is going to be 5 times 4 minus x. So we've got 5 times, let me skip a line. We've got 5 times 4 minus x to the 4/5. We've got, this is going to be our common denominator. This is already over the common denominator, so we're just going to leave it as a minus x. This, though, needs to be multiplied by 5 times 4x minus 1. So we have plus 5 times 4 minus x to the 4/5 times 4 minus x to the 1/5. Okay, combine these together. These are the same. Add the exponents. We get 5/5, which is 5 times 4 minus x. So we have minus x plus 5 times 4 minus x over 5 times 4 minus x to the 4/5. And we can simplify it a little bit further. Distribute. This is going to give us 20 minus, we have a minus x plus 20 minus 5x over the common denominator, which is the CD here. Now, for the common denominator, we can see that if x is a 4, this would be undefined. So x equals 4 is a point of interest. And if we set the top equal to 0, this gives us minus 5x. So we have actually minus 6x rather, minus 6x plus 20 over common denominator. That gets c equal to 0. So negative 20 divided by negative 6 is 20 over 6, which is 10 over 3. So 10 over 3 is another point of interest. Now, for the first derivative test, we need to check these intervals. But rather than, so our intervals are going to be from like, say, negative, this is 3 1/3. It's going to be from like negative infinity to 4/3, or to 10/3 rather. And our other interval is going to be between 10/3 and 4. And our other interval is going to be from 10/3 on to positive infinity. So those are our intervals. And then we've got these factors to consider. We've got this, I guess we could call it 6x plus 20. And in our denominator we have this 5 times 4 minus x to the 4/5. So that kind of gives us our columns and our rows. So you can complete that chart. What I'm going to do is put these intervals on a number line. So we've got 10/3 here, and we have 4 here. So in effect what I'm doing is this here corresponds to this interval, this corresponds to this interval, and this corresponds to this interval. And what I'm going to do here is pick a number a little bit less than 10/3, let's say 3. And between here, between 3 and 4, maybe I'll pick like 3.5. And maybe I'll pick a 5. So I'm going to pick those, check those with the original factors, and see what kind of a sign we get. So taking a 3 and going into this with a, with a 3, I have a, well, I guess this one with a 3, I have a minus 18 plus 20. That's going to give me a positive in the numerator. And in the denominator, if I have a 3, this is also going to come out to be positive. So this is positive. And that's exactly what you would find if you did each of these factors. You got plus, plus, which gives you overall increasing. For this range in between here, we're looking at 3.5. Negative 6 times 3.5 is negative 21. Negative 21 plus 20 gives us a negative. And in the denominator, we put a negative 3 in, or we put a 3.5 in. 4 take away 3.5 is still positive, so this is going to come out to be positive. So that gives us a negative over that range. And then we're going to use 5 for the last outside part. We get negative 30 plus 20. That's going to give us a negative. And in the denominator, we're putting a 5 in, right? Yeah. 4 take away 5 is a negative 1. This is going to be a negative. It's a 5th power. So this is also going to be a negative. So that gives us a plus. So we can see from analyzing the sign changes that we have positive through 0 to negative, which means that this is going to be a relative maximum. And for this pattern here, we've got a negative slope tangent line through 0 back to positive, and that's going to give us a relative minimum. So that's how we can do that. We got a max and a min there. Now let's go and do the second derivative test. So we need to take the simplest version of this that we have, which I guess would be this one. And now we have a quotient, so we have to use a quotient rule. And the quotient rule, if we let this be u and this be v, we have v du minus u dv. Now I'm using Newton's notation instead of Leibniz, which is the prime notation, but same idea. So first, or the bottom derivative of the top minus the top derivative of the bottom over the denominator squared. So that's the rule for dividing two quotients. So and this 5 doesn't really matter, so that's what we're going to do here. So we're going to do v du, so we're going to do the second derivative. V du, 5 times 4 minus x to the 4/5 times the derivative of the first, which is going to be a minus 6, minus u dv, which is minus 6x plus 20, times the derivative of the bottom, of the denominator, which is going to have our 5 out here, but we're going to have 4/5 times 4 minus x to the minus 1/5. We're going to do 4/5 take away 5/5, which is minus 1/5, times the derivative of the inside, which gives us a minus 1, over v squared. No, so what v squared is going to do is make this an 8. So I'm just going to leave it in exponent form. So I squared the bottom, so 4/5 times 4/5 is 8/5. So there we have the second derivative. Needs to be simplified. Hopefully there'll be some like terms we can do something with here. This first part here, I got it like a negative 30 times 4 minus x to the 4/5. My minus sign. Looking at this part here, 4/5 times 5 is going to cancel out. Got a negative. This negative will actually turn that into a plus. So take care of that. And what else we got? We got this times this. We have minus 6x plus 20 times 4 minus x to the minus 1/5. All of this over this d actually stands for this 5 times 4 minus x to the 8/5. Now what we want to do is simplify this numerator, and then we'll worry about how that might combine with the denominator later. So just looking at the numerator part here, we're just going to take this and kind of do this as a little bit of a side problem. Okay, this is with positive exponent, so this is going to basically, so what we're going to do is, because of this negative exponent, this is going to be a rational expression with a single term expression here, and we're going to have to find a common denominator and combine those. So if I take the first part, we've got a minus 30 times 4 minus x to the 4/5 plus, and this part here we have a minus 6x plus 20 over 4 minus x to the 1/5. So this negative exponent means it needs to drop to the bottom. And then all of that is still over this 5 times 4 minus x to the 8/5. But we're just kind of focused on this numerator right now. So let's see what we need to do with the numerator. Ignoring this bottom part, the common denominator is going to be 4 minus x. So we're going to have 4 minus x to the 1/5 power and so this one was over, basically over 1, so we have to multiply this term by 4 minus x to the 1/5. So 4 minus x to the 1/5 times 4 minus x to the 4/5 is going to give us 4 minus x to the 5/5, which is just basically 4 minus x to the 1. And we're going to have a minus 30 times 4 minus x out of that part. This other part then, the second term here, is already over the 4 minus x to the 1/5. So we have minus 6x plus 20. So that's good. This looks like it's going to simplify, and then we're going to end up with that. And again, we've still got this common denominator, which is 5 times 4 minus x to the something fifths. Where are we at on that? To the 8/5. It's always good as you're going through a lot of steps to kind of try to double check and make sure you're keeping your exponents and everything the same and you're transcribing everything. So I guess we can multiply the, what we got here? This is not a 4 minus, so let's multiply this out. We have a minus 120 plus 30x plus a minus 6x plus 20. All of that over 4 minus x to the 1/5. And again, now this is just the numerator. We've still got the denominator down here. So let's see, 120, negative 120 plus 20 is 100, and we got 36x, 24x plus 100 in the numerator over 4 minus x to the 1/5, the fifth root of 4 minus x. What the hell are you doing that for? Let me pause this. Okay, so what else can we do with that? We can see here that if x is a 4, this part's going to be undefined. If take away 100 and divide by 24, so minus 100 over 24 is minus 50 over 12, which is minus 25 over 6. So minus 25 over 6 would give us a 0 for the numerator part there. And what else we got? I don't really see anything else. And then this denominator now, a 4 would cause the whole thing to be undefined. So we've got that 4 over again. So it looks like these are the points of interest that come out of this second derivative. So the whole second derivative is going, I don't know if this would well, yeah, this 8/5 is going to simplify. So let's look at this. So we have, so this might have been a little bit too soon to try to simplify that. So you got that 4 minus x to the 8/5. So what we're going to, so we've got this divided by this. So we can kind of pretend that this is a fraction by putting it over 1. So dividing by a fraction, you multiply by the reciprocal, you change flip. So you're going to keep the numerator, 24x plus 100 over over 4 minus x to the 1/5 times 1 over 5 times 4 minus x to the 8/5. Okay, so it's taking care of the numerator and the denominator. Now 8/5, this is the same argument here. So 8/5 and 1/5 is 9/5. So we have 5 times 4 minus x. That takes out 5/5, and what's left over is 4/5. 4 minus x to the 4/5. So I'm going to break the 9/5 up into 2 terms in case it can simplify. It probably doesn't make a difference. And we have 24x plus 100 in the numerator. Okay, so this is what I have as a simplified second derivative. And again, okay, so take care of the numerator. Minus 100 divided by 24, you get a negative 25 over 6. 100 over 24, which is 50 over 12, which is 25 over 6. And in the denominator, if x is a 4, either one of these terms is going to cause this function to be undefined. So I think that's what we have as our points that we need to check for with the second derivative. So let's evaluate this at 4. If we put a 4 into this, we're going to have something, you know, like 196 in the numerator, but we put a 4 into this, it's going to be undefined, so we can't really do anything with that. This is where really we might need to do like more like the interval thing. Putting negative 25/6 in there, negative 25/6 in here, that's going to be negative 100 plus 100, that's going to give us our 0 out. So, so we know that these are the right numbers. But let's kind of do this interval test. Again, instead of doing the chart for the ranges, I'm just going to kind of do this as a number line. So we got negative 25/6, which is negative 4 1/6. And here we have 4. So we've got these intervals. Let's see. So we got these 3 intervals to consider here. So let's look at a number less than a negative 4, like a negative 5, and put a negative 5 into this and see what we get. So we put a negative 5 into this, we have negative 120 plus 100. That's going to be a negative in the numerator. Put a 5 into this. This is going to be a negative. This is going to be a negative. And a negative times a negative makes a positive. So we've got a negative over a positive. That's going to give us a negative. Let's look at the interval in between negative 4 1/6 and 4. 0 is a good point to use. So I did negative 5 there. Put a 0 in here, we get 100. Here we get 5 times 4 times 4 to the 4/5. So 5 times 4 is 20. 4 to the 4/5, which is the 5th root of 4 to the 4th. It's going to come out positive. So we have positive over positive. That's going to give us a positive in the middle. That means we're going from negative curvature to positive curvature there at this point. And let's look at a little bit past 4. Let's look at 5. Put a 5 in, we get positive in the numerator. We get negative, and this is going to be negative. So we got positive over negative, negative. We have positive here. So this points to 4 being an inflection point, and negative 4 1/6, since the rate of change is going from a negative rate of change to a positive rate of change. We'll see what this comes out to be. Let's look what else. So I'm thinking to do the graph of this. We need to find the value at 4 of the original function. So we put a 4 into this original function here. We have 4 times 4 take away 4. We have basically 0 here. So 4, 0. And let's see what else. If we put a negative 4 1/6 in to this, we have 4 1/6. Go up here, 4 1/6. Well, let's do the fractions. Let's do 25 negative. It's a negative, right? Negative 25/6 times 4 minus 25/6. So 4 minus a minus 4 1/6 is 4 plus a 4 1/6. This is going to be 8 1/6. So we have 8 1/6, which is 48 49/6. And we want the 5th root of that. So I think it's time to bring out the calculator on this and see what we get. Let's look here. So negative 25/6 times the 5th root, or the 1/5 power of 49/6. And the 1/5 power, 1 divided by 5 is 0.2, so same thing as raising it to the 0.2 power. And we get negative 6.34, negative 6.3. So if I was to try to start sketching the graph here, at 4, we're going to have a 0. And at negative 4 1/6, we're going to have a negative 6.23. So that's almost 6 1/4. So right around in here. We can go back to the first derivative test here. And with the first derivative at 4, we have the slope of the tangent line going from negative to positive, from decreasing to increasing. That's at 4. Did that backwards. From decreasing to increasing. So you kind of got that pattern going on there. And at 10/3, which is 3 1/3, 1, 2, 3 1/3. Let's see what the value is at 3 1/3. Put 10/3 into the original. We have 10/3 times 4 minus 3 1/3, which is 2/3 to the 1/5 power. So let's see what that is using the calculator. So you have 10/3 times 2/3 to the 1/5 power, to the 0.2 power. And we get 3.07. So at 2/3 we have 3.07. So at 2/3, at 10/3, we have 3.07. So we got that point there. And the first derivative tells us that that is a maximum. So we have this going on. Now down here, this I'm thinking is an inflection point, but we'll see. But for this part of the graph, we kind of have this going on. And we'll see what goes on down here. So let me graph this on the graphing calculator, and then we'll kind of check and see how it might look. So we got, let's see, x. Let me clear this out. We got x times 4 minus x to the 1/5 power, which is to the 0.2 power. Let me check my window here. Yeah, my window's been zoomed in, so I want to go zoom standard, and then we'll adjust the window from there. Let's see what we got. Okay, so we're close. What's going on here is at this point here, this is actually an inflection point, and it comes down further like this. We got this part, and then this part here just kind of comes through like that. So the graphing calculator says we have this part, and it kind of comes down like this, and this part here kind of comes up. So it kind of implies that this is an inflection point right in here, where the tangent, you could look at it, sort of looks like it's curving like this though, but it looks at some point here, the tangent's positive, positive, positive. Here you got a 0 tangent line, so that's going to be your maximum. This looks like it's an inflection point here, and then it kind of changes, but there's no real minimum or maximum, so it kind of changes there. So this function would be kind of hard just to graph by using the critical points, but based on what we went over, you know, we identified a couple of the points that are of interest there. So I would try to do a better job on this over the weekend and submit a better video on this, but that's what I've got for now. So we're at